We know about functions, we know about relations, we know domain and range. Okay, fine. But how do we verify that we indeed have a function just based on the algebraic representation? Okay, and more specifically, there's some language associated to functions, right? So if we have like y equals f of x, we say this little bit of language, y, so if y is equal to f of x, so y is equal to f of x, right? We can say y is a function of x, right? So, okay, how, if we're not given that notation though, y equals f of x, how do we know if it's a function? Okay, we might have an equation. Here's what we do. We have to solve the equation for y. And then if the solved equation has at most one solution for y, for each value of x, again, idea of a function, we have one for each element of the domain, there is one range element. So for each x, there's one y. Okay, then we have y as a function of x. Okay, so okay, let's just get some practice with this. Y, okay, does this define a function of x? So it says solve the equation for y. Okay, I can solve this. I want to solve for y. That means I need to subtract x from both sides. X squared rather. Okay, so I have y squared is equal to 1 minus x squared. Okay, isolate y by applying a square root on both sides. Okay, and when you introduce a square root, you need the plus and minus. Okay, I'm going to say that over and over and over because we forget the plus and minus. When you introduce the square root, you need the plus and minus. Okay, so I have y equals plus or minus square root of 1 minus x squared. Okay, so if the solved equation has at most one solution for y, okay. So y is equal to plus or minus. Okay, actually, listen to what I just said. Y equals plus or minus, right? So there's two solutions, right? So this one is not going to be a function of x because I have plus or minus y. Okay. All right. So y is a function of x. Okay. Does x squared plus y equal 1 define y as a function of x? So I need to, again, solve for y. So if I solve for y, I need to subtract x squared from both sides. Y equals 1 minus x squared. Okay. So here, if I insert x, right, I calculate y according to this rule. Okay, it seems like if I insert an x value, I do this. If I insert a single x value, I get one y value. So yes, this is a function of x, or y is a function of x. Okay, so we can actually write f of x is equal to y is equal to blah, blah, blah in this case. Okay, again, I got one y value for one x. Okay, does x squared plus y define, or x plus y squared equal 1 define y as a function of x? Okay, so if I solve, so this means I need to solve for y, so y squared, so subtract x from both sides. Okay, y squared is equal to 1 minus x, square root, y is equal to plus or minus since I introduced the square root. Okay, so this one is no because I have the plus or minus. Does it define x as a function of y? Okay, so now here the variables change. So this means I need to solve for x, right? Okay, define x as a function of y. So I have to solve for x. Okay, so I'd subtract, so I'll just write it out to begin with. X plus y squared equal 1. So I need to solve for x. Subtract y squared, subtract y squared. X is equal to 1 minus y squared. Okay, so this language means we would insert y and we would find x based on that y value. So if I insert y, do this rule, and I get x. Do I get a single x? Yep. So this is, so this expression, if I solve it for x, then x is a function of y. Okay. And our next example has a more complicated equation. Okay, fine, whatever. Just have to work a little bit harder. Define y as a function of x. Okay, so if I look at this, first, there's a lot of stuff going on. Let's just do some algebra and simplify. So I'm going to distribute. Okay, so I have y minus x squared is equal to 3x minus x squared minus y. Okay, and now it says define y as a function of x. So this means I need to get y alone. I need to solve for y, right? So if I solve for y, I would need to add y, okay? And, well, if I'm putting y's on the left, let's move the x's over to the right, plus x squared. Okay, so here, let's see, if I add y to y, I get 2y adding like terms, and then I'd get 3x. Negative x squared plus x squared would cancel out. So I think that's it, because the y's would cancel out, those would reduce, those would reduce, those would go, okay. So, okay, I need to completely solve for y, so divide by 2, okay, and I just get y is equal to 3x over 2. And just a note, if you really wanted to, you could write this as 3 over 2 times x, right? There is multiplication, and you can rearrange it however you wish. Okay, so the question is, does this define y as a function of x? If we insert an x value, do we get one y value out? And the answer is yes. Okay, so this is a function of x. So we could write f of x is equal to 3 over 2 times x. Okay, so when you're encountering the language y as a function of x, right, that means y has to be isolated, and then also for any input of x, you get one output for y, okay? Also, we went through an example where we had the language reversed, where we had x as a function of y, right? So just be careful what the language is saying. You may need to solve for the other variable.